Assalamu alaikum and hello everyone. I am Rezaul Karim and in this video I will present a short summary of the research paper titled A Taxonomy of Virtualization Security Issues in Cloud Computing Environments. I will briefly explain the objectives, main security challenges, common attacks and the solution proposed in the paper. Let's begin. At first, we will see the objectives of the study. Main goal to explore and classify the security challenges associated with virtualization in cloud computing and identifying effective solutions to address them. Specific objectives are identify security risks, analyze how virtualization introduces vulnerabilities in cloud computing, for example, VM isolation failure, insecure migration, etc. Second objectives is classify and categorize vulnerabilities. In these objectives, develop a taxonomy like structured classification of different types of virtualization related security issues based on characteristics and system layers. Third objectives is investigate threats and attacks. Understand how attackers exploit vulnerabilities leading to data breaches, service hijacking, VM escape, and many more. Fourth objective is review and compare mitigation techniques, like examine various security frameworks, tools, and methods proposed in the literature. Here we can evaluate them using the five core criteria like data confidentiality, data integrity, hypervisor security, and VM protection and access control. The end goal of this study is help cloud service providers and IT professionals build stronger, safer, and more reliable virtualized environments. In the next slide, we will know what is cloud computing and virtualization. Cloud computing, it is a model that allows users to access computing resources like storage, servers, and apps over the internet on demand without owning or managing physical infrastructure. For example, Google Drive, Amazon's, Microsoft Azure. Users only pay for what they use, and this offers scalability, flexibility, and cost efficiency. And what is virtualization? It is a technology that allows multiple virtual machines to run on a single physical machine using a software layer called hypervisor. Here, each VM behaves like a separate computer with its own operating system and makes better use of hardware resources, enables features like isolation, resource sharing, and migration. Why virtualization is key to cloud computing? Because cloud providers use virtualization to deliver services such as IaaS, infrastructure as a service, PaaS, platform as a service, and software as a service. Without virtualization, cloud computing would be less flexible and more expensive. But there are cases. While virtualization is powerful, it introduces new security challenges such as VM escape, malicious VM images, and weak isolation. This is where the study focus making virtualization secure. In this new slide, we will know virtualization architecture. What is virtualization architecture? It refers to the structure or model that defines how virtual machines interact with the host hardware, hypervisor, and operating system in a cloud environment. Two main types of virtualization architecture there are. The first one is hosted architecture. How it works? It works like as an operating system is installed first. Then a hypervisor runs on top of that operating system. VMs are then run using this hypervisor. Use case: software testing, running multiple operating systems like Windows and Linux together. There are some weaknesses such as less secure. If the base operating system is hacked, the attacker may access all VMs, and higher latency due to extra software layer. The second one, bare metal architecture. First, we will know how it works. The hypervisor installed directly on the physical hardware, no operating system needed. VMs run on top of the hypervisor. It is used in enterprise cloud platforms like Google Cloud and data centers needing high performance and security. Why does this matter? Because the type of architecture impacts both performance and security. Hosted architecture is easier to set up but more vulnerable. Bare metal is harder to attack but more complex to manage. In this new slide, we will know the methodology of this study. How was the approach of this study? The researchers used is systematic literature review called SLR, a structured way to collect, analyze, and interpret existing research on virtualization security. Why use SLR? Because to avoid bias and cover all available evidence, and this helps answer the study three main research questions accurately and ensures the findings are based on solid and diverse source. The research process overview are the database searched. They searched, they searched well-known academic databases like IEEE, Explore, ACM Digital Library, Google Scholar, and Springer Link, Scopus, and while new online, etc. Keyword they used some keywords. The used combination words are virtualization, security, threat, vulnerability, attack, solution, etc. Initial result found that uh, 53,324 papers. They filters they filter some steps like remove irrelevant topics like mobile, e-commerce, storage, and read abstract and conclusions. Fully reviewed 400 selected papers, and final selection is on 48 high quality relevant studies. They excluded papers if they were not in English and did not focus on virtualization in cloud computing, lacked security or mitigation relevance, and if there are just editorials or overly specific case studies, then they exclude that papers. They included papers if the paper discussed virtualization vulnerabilities, risk, and attacks, and if the paper proposed mitigation techniques for virtualization threats. In this new slide, we will know the main research questions. To guide the study, the authors designed three key research questions focused on virtualization security in cloud computing. Each question aims to explore a different stage of the security problem lifecycle, from identifying issues to understanding how attacks occur, and finally to finding ways to solve them. Research question 1. What are the main vulnerabilities and risks associated with virtualization in cloud computing? The goal of the first question is identifying technical weakness in virtualization. For example, poor virtualization machine isolation, insecure hypervisors, risky VM migration. They focused on creating a taxonomy, structured classification of these issues. The second question is what types of threats or attacks exploit these vulnerabilities. The goal of this question is show how attackers take advantages of weak points. For example, VM escapes like breaking out of a VM to control others, and malicious VM images, hypervisor hijacking, etc. The third question is what security mechanism or techniques can mitigate this risk? The goal of these questions is explore existing and proposed solution to defend against attacks. This question includes hypervisor protection tools and memory isolation, live VM migration security, etc. Each solution is evaluated for effectiveness using 5 key criteria like confidentiality, integrity, hypervisor security, VM security, and access control. In my next slide, I will briefly discuss classification of vulnerabilities. What is a taxonomy? In this study, a taxonomy is a structured way of grouping and categorizing different security vulnerabilities related to virtualization. This helps understand where problems exist and how they are connected. Six major categories of virtualization are: the first one, virtualization characteristic related issues. Problems inherent to how virtualization works, for example, poor VM isolation, risky VM migration, outdated VM snapshots. The second is infrastructure issues, such as weakness in hardware, hypervisor, or VM image management. For example, insecure hypervisor, VM image sharing, unprotected shared clipboard. The third one is access and communication security issues. It is risk related to data transfer and authentication. For example, weak login system, insecure communication channels between VMs. The fourth one is data security issues. It concerns about protecting sensitive information like poor credential management, improper data deletion, privilege misuse. The fifth one is control and monitoring issues. It challenges in managing and observing virtual environments like invisible traffic between VMs, monitoring tools being compromised. The last and sixth one is security policies and rules issues. It issues arising from lack of guidelines or poor user awareness. For example, static policies that don't adapt users aware of cloud threats. Now we will discuss about sample vulnerabilities. In this slide, we explore real examples of vulnerabilities from each of the 6 categories introduced in the taxonomy. These are specific weak points that attackers can exploit in a virtualized cloud environment. The first one, VCN, incorrect VM isolation. VMs should be kept separate, but flawed isolation may let a malicious VM access or interfere with others. For example, one VM might spy on another's memory or traffic. The second one is ION, insecure hypervisor. The hypervisor controls all VMs. If compromised, attacker can control the entire virtual machines. For example, hyperjacking attacks gain control over all guest VMs. The third one is AC2, insecure communication channel. Data exchanged between VMs or between VM and host may not be encrypted. Attackers can intercept or manipulate this traffic. The fourth one is DON, improper data sanitization. When a VM is deleted or reused, old data might still remain on storage. This leads to data leakage or unauthorized access. The fifth one is CON, lack of visibility. VM to VM traffic doesn't pass through physical network tools like firewalls or IDs. As a result, malicious behavior can go undetected. The last and sixth one is PON, lack of security policies. Without clear rules, users and admins may configure VMs insecurely, skip updates, or overlook access restrictions. This leads to a higher risk of accidental or intentional breaches. These real-world examples show that vulnerabilities exist at every layer from hardware to human decisions. Identifying and fixing them is key to securing cloud virtualization. In this new slide, I will discuss common attacks in virtual environments. After identifying vulnerabilities, this slide shows how attackers exploit them through real-world attackers on cloud virtualization systems. These attacks can lead to data threat, service disruption, or total control over cloud resources. The first one is VM escape. The attackers break out the VM and gain access to the host system or other VMs. Critical breach can compromise the entire virtual infrastructure. The second one is VM hopping. On malicious VM jumps to another co-located VM on the same physical machines that can exploit weak isolation or shared resources. The third one is malicious VM image. Attackers uploads a pre-infected VM image to a public repository. When users download it, their cloud environment becomes compromised. The fourth one is hypervisor hijacking. The attacker takes control of the hypervisor itself, gaining greatly access to all VMs, one of the most dangerous forms of attack. The fifth one is VM rollback attack. A VM is reverted to an older snapshot and contains unpatched vulnerabilities. Attackers use this trick to reintroduce known weakness. The sixth one is denial of service, that is called DOS, by a VM forcing. A malicious VM uses more than its share of CPU or memory, starving the VMS, can crash or slow down legitimate service on the host. The seventh and the last one is malicious insider threat. Someone with unauthorized access, like an employee, misuse privilege, and especially dangerous due to their insider knowledge and access. These attacks are not theoretical, they are already happening in the real cloud environments. They show why securing visualization is absolutely essential in cloud computing. In this new slide, after identifying vulnerabilities and understanding attacks, this slide focuses on how to protect virtualized cloud environments using smart security solutions. These tools are frameworks, and frameworks aim to secure hypervisors, VMs, memory, migration process, and communication channels. The first one is HyperSafe. It protects the hypervisor from being modified or hijacked, uses control flow integrity and memory protection to stop low-level attackers, keep the brain of virtualization safe. The second one is CloudVisor. Works below the hypervisor and controls access, VM memory and input output. Even if the hypervisor is compromised, VMs remains protected, and it focuses on isolation and confidentiality. The third one is Defender. It uses virtual machine introspection to monitor VMs from the outside. It can detect malware and suspicious behavior without being seen or affected by it. The fourth one is Hyperwall, hardware-based solution that protects VM memory using encryption keys and access controls, prevents unauthorized access from other VMs or the hypervisor itself. The fifth one is SLVM, Secure Live VM Migration. Secure VMs during migration from one server to another and adds encryption and verification to prevent man in the middle or rollback attacks. The sixth one is VM Wall. It is a virtual firewall that filters traffic between VMs and uses introspection introspection to identify malicious process and prevent data leaks. Now in the new slide, we'll see the comparison of security solutions. This slide presents a side-by-side comparison of various virtualization security solutions based on the 5 essential criteria. They are confidentiality, integrity, hypervisor security, VM security, and access control. Confidentiality, it does it keeps sensitive data private and encrypted. Integrity checks if does does it prevent data tampering or unauthorized changes. Hypervisor security checks, can it protect the hypervisor from being hijacked or compromised. And VM security checks, does it protect individual VMs from internal or external threats. And access control checks, can it manage who can do the what. Here are some key observations. Like CloudVisor offers the most balanced protection across all 5 areas. HyperSafe is excellent for protecting the hypervisor but does not directly protect VMs or access control. SLVM is specialized for live migration security with strong VM and access protections. VMall is more focused on VM level security and traffic filtering but does not secure the hypervisor. In this slide summarizes the most important insights from the entire this thesis paper. It brings together everything we have learned about virtualization, its risk, and how to secure it. First, virtualization is powerful but risky because virtualization makes cloud computing cost effective, flexible, and scalable, but it also introduces unique security challenges like VM isolation failure, hypervisor vulnerabilities, insecure VM migration, data leakage, and weak access control. And real attacks are already happening because threats like VM escapes, hypervisor hijacking, and malicious VM images can cause us data breaches, system takeovers, and service failures. Attackers often exploit invisible internal channels or shared resources between VMs. The third one is security must be multi-layered. Protecting cloud virtualization requires securing all layers like hypervisor, VM memory, communication paths, migration process, and user access and policy enforcement. And many effective solutions exist for this, like some tools like CloudVisor, HyperSafe, Hyperwall, and SLVM provide powerful defense mechanism. No single tools is perfect. Combining multiple strategies offers the best protections. The taxonomy helps simplify complex risks and grouping vulnerabilities into 6 categories help developers and cloud providers like understand where weakness exists, track how threats related to them, and apply targeted solution. The final message is to build secure cloud system we must not only rely on virtualization, we must understand its risk and defend it at every level. In the conclusion, we can say securing cloud virtualization requires careful isolation, monitoring, and access control, and hardware plus software based protection, and clear policies and user awareness. The future work may be improved real-time detection and lightweight solutions. Thank you, sir.